Hey SM3, so you may or may not be coming from 11.5 since we're covering that section and this section together, but in 11.5 we learned about the area of a pyramid. So in the area of a pyramid, we learned that volume of a pyramid, we learned that we take the area of the base and multiply it by its height, but then after we do that, we divide it by 3 or multiply it by 1/3, and that's the area of this figure right here. Thing about a cone is that a cone is almost essentially the same shape as a pyramid. It's not a polygon base, it's a circular base, and so it's actually pretty much the same thing. So in this case, the volume is still the same. The volume is 1/3 of the base times the area of the base times the height, but in this case, uh, base is circular, so the base is equal to pi r squared. So volume is equal to 1/3 times by pi r squared times by the height, and that's a volume of a cone. Okay. So let's go ahead and try that out. And so it doesn't like it shows here. It doesn't really matter if the cone is slanted, if the center of the cone, or if the vertex of the cone is either directly above the center or not at all. Okay, it doesn't really matter. Okay, so we know volume is equal to 1/3 of the area of the base times the height. So let's find the area of the base, and the area of the base again is it's the circle, so it's pi times the radius of the circle, which is 2.2, and so radius squared. So right there. So if we do 2.2 squared, let me go ahead and do that in my calculator. I get 4, so it's equal to pi times by 4.84. So multiply that by, I'm actually just going to keep it right there for now. Okay, so that's the area of the base. So 2, our volume is equal to 1/3 times by the base. So this is also going to be centimeters squared. So 1/3 times by 4.84 pi times by the height of our cone, which is 4.5. So if you perform these calculations together, so for me, what I'm going to do is I'm going to do 4.84 pi, multiply that by 4.5, and then I'll divide that by 3. Okay, so let me show you what I'm doing here. So I'm going to take 4.84, multiply that by pi, and then multiply that by 4.5, which is the height. Okay, and then I'm going to take that and divide it by 3, and I get 22.81. So 22.81 centimeters cubed. And that's the volume of this cone right there. Alright. And that's pretty much all there is to it for finding a cone. It's just you gotta find the area of the base. The good thing about something like finding the area or the volume of a cone versus finding the area of a pyramid is that the volume of a pyramid, the area of the base can differ, right? So we can have a square base, a triangular base, a pentagonal base. But the nice thing about cones is that the base is always circular, so you only need to use pi r squared to find the area of the base. Okay, so you guys can go ahead and do these ones. So like this, these two examples here, this example here, you guys can go ahead and use the formula to find those ones. Okay. Same with like something like 4. So 4 doesn't give you a figure, but Again, volume is equal to 1/3 times pi r squared times height. So in this case, you have that r is equal to 5, okay, and has a height of 13 feet. So you can use those, so you get the volume is equal to 1/3 times pi 5 squared times by 13. So that's equal to 1/3 times 25 pi times by 13. So plug that in, and you should get your answer. Okay, so in 6 right here, it says a right cone has a volume of 528 cubic meters and a diameter of 12. Okay, so all these you should just be using this formula. Volume is equal to 1/3 times by pi r squared times by the height. But you notice that in this equation, it gives you the volume. So I know the volume is equal to 528. And I have that the diameter is equal to 12 meters. So that means the radius is equal to 6 meters. And we're looking to find the height. So the height is what we're trying to find. So I can plug in these values. So 528 is equal to, just FY, so another way to write this, if you want to, instead of doing 1/3, you can do pi times by r squared times by the height, and then you can divide it by 3 if that makes you, if you guys like it better, or if you want to just keep 1/3 out there, doesn't matter, it's still the same thing. Okay, so I'm going to find the height in this case, and so because I have a denominator of 3 and I'm solving for h, again solving for this, I'm going to multiply both sides by 3. Multiply this side by 3, multiply this side by 3. Okay, so I get 528 times by 3, which is 1584. Now on the right side, because there's a 3 on the numerator and the denominator, they cancel, and I'm left with 36 pi times by the height. And then I'm going to divide by 36 pi on both sides, and that will give me my height, as 36 pi will cancel on the right side, and I'll just be left with h. So h is equal to 1584 divided by 36 pi. So 1534 divided by 36 pi, and I get that the height is about 13.6. Okay, about 13.6. Okay, there you go. Now in example 4 down here, we're going to find the volume of what we call a composite solid. So a composite solid, kind of like where you have multiple, you have to take into account more than just one solid, multiple solids. So in this case, we have a solid, a composite solid that consists of a cylinder, but then it also consists of a cone on top of that cylinder right there. Okay, and so really the only thing that we need to do in a composite solid is either, it depends, so sometimes you might have something like, I'm not sure how well I could draw something like this, but let's say that we had a something similar. Say that we had something like a cylinder, but it was hollowed out with a something down the center right there. Okay, and so this is also a composite solid, but here there is a volume of the cylinder that is missing. Okay, so the thing about either one is that you are either going to be adding the two solids, or in this case right here, you'll be subtracting. You'll taking this one, you'll take the volume of the whole of the entire 3D solid, and then you'd have to subtract out the area inside right there. So in this case right here, we're just going to take the area of both the cone and the cylinder and add them together. So when dealing with composites, you're either going to be adding or subtracting area. So in this case, we'll be adding. So let's find the volume of the cone. So volume of the cone is equal to 1/3 times the area of the base, so pi r squared, times by the height. So in this case, it's going to be 1/3 times by pi times by the radius. Now the radius of the cone is just the radius of the cylinder. So it's going to be 6 squared times by the height. So the height of the cone is 4. And so I get 1/3 times 36 pi times by 4. So when I punch that into a calculator, I get 36 times by 4. And then I need to multiply that by pi and divide that by 3. And so when I do that, I get about a volume of 150.8 roughly. And now for the volume of the cylinder. The volume of a cylinder is just the area of the base times the height. So again, that's what we learned last time. So we just need to take the area of the base, multiply it by the height of the cylinder, because the area is consistent from base to base. And so the area of the base is just pi r squared, and the height is 5. So multiply by the height. So in this case, it's pi times by 36 squared, or not 36, 6 squared, times by the height, which is 5. So it's pretty much just like the same thing as if you haven't noticed. The volume of the cone and the volume of the cylinder is almost the same, except you don't take a third of it. Okay, so we can essentially just take whatever this part is, but without dividing it by 3. So we'll do 6 squared, or 36, okay, times by pi times by the height. So this volume is going to be equal to 565.5 about. And then so the volume of this composite solid is going to be equal to the sum. So I take the volume of the cone, add the volume of the cylinder, which is 565.5. And when I do that, I get 716.3. And that's going to be meters cubed. Okay. Alright, and that's it for finding the volume of a composite solid. So you can go ahead and do the same thing here. So it's a cone again on top of a cylinder. Okay, but that should wrap it up for 11.6.